This is a project to develop a machine learning model to solve a problem. The task is to build a model to predict electrical energy output based on given features. We have a CSV file with a large set of data, which large set of data, and this is the temperature, pressure, humidity, and vacuum. So this is our dependent variable, and we can use these features to build a model. We can start step by step. First, to identify the model. In our case, this is supervised learning. And our objective is to predict a target variable, which is energy output when we have given observations. In supervised learning, we generally have a large set of past observations, which we do have to use for training, as well as the associated target variables for each of these observations. So we have all of this, and that's why it's supervised learning. Next, we will determine which features we are going to use and identify the algorithm. So I'm going to identify dependency between each of the features, between temperature, pressure, vacuum, and all of them. For that, I built scatter plots for each variable. In this case, we will see scatter plot for pressure. There is not much dependency. Next one is humidity. A similar scatter plot doesn't show much dependency. Next one is vacuum. Dependency is quite clear. We see correlation. And next is temperature. This correlation is very clear. So in our case, we will choose. I will choose multiple regression because we have several features. We have several variables, but I will use the same algorithm for both of them, multiple regression, but I will use, in one case, just two most dependent variables, which is vacuum and temperature. And in another algorithm, I will use four of them, all variables which are given. And we will see what the difference will be between those models if those two variables which don't show good dependency will give just the noise, or they will benefit in the model. So next we will split our data set. What I'm going to use, I assume that this is a normally distributed, and it's random, each of them, but I will make it more random. I will use the random formula. So that's how I did it. I used random formula, then I sorted it and make selection 80% of this data. I made a training set, and 20% is a test. So next, I will use statistical approach to identify if this is a statistically significant approach. In this case, I'm building regression, multiple regression, using this test, using this training data set. And we see all statistics here, intercept and vacuum and pressure. So we also see probability in ANOVA, which is 0. It means and it's less than 0.5. In this case, this is a statistically significant. To build, and this is a training set. So we can build the same model to using our test. This is the formula which is used for our training set to identify the same value for energy. for our test set. When we use temperature plus multiplied by coefficient, then vacuum multiplied by coefficient, pressure and humidity, and plus the intercept. And this is a predicted value. We can see how different, what the difference between predicted value and real value in test set. Sometimes it's close, sometimes there is a difference. And we also see what the intercept maximum minimum value in the lower and upper level for our confidence interval. It's quite big, I would say. So then similar model with just two variables. I did the same and to use only two variables. I built all the statistics and then using forecast in our test data just for two variables. We can see how that this data is quite close, much better than when we used four variables. So the first one, 452, that's our forecast for 80, 483, our forecast 436, real one, 437, our forecast 464, real one, 464. So the forecast is quite right, like very near. And I would say the difference between upper and lower level, it's much less than, it's like almost standard deviation. It's much less than when we used four variables. So I would say that the preference would be use our first model when which is just two variables, temperature and vacuum. And two other features provide, I would say, more noise. But both models are good and shows that the results would be statistically significant. But the model with two variables, it's our preference. So we answer all questions, all of them, and this is the final. I just explained that the result is our second model. Thank you for your attention.